In this video, we're doing free response question 2013, question number 3. Question number 3 is a no calculator question, so keep in mind you do not get your calculator on this one. Take a moment and familiarize yourself with the question, and then we'll get back. Thank you for reading the question. Let's take a look at part A. So we've got hot water dripping through a coffee maker. Fill in a large cup with coffee. The amount of coffee in the cup is given by the differential equation. So we've got, this is an amount. So let's keep in mind that it's an amount. In part A, use the data in the table to approximate the derivative at 3.5. Well, 3.5 is between 3 and 4. A derivative is a slope, so we're going to go 12.8 minus 11.2 over 4 minus 3. If we do that, we get 1.6. They want us to show the computations, which we did here, and indicates the units of measure. So notice it's ounces per minute. So ounces per minute. And notice, again, computations, answer, units. Part B. Is there a time t in the interval from 2 to 4 where the derivative is 2? Well, so this gets to the crux of the mean value theorem. And so the mean value theorem, MVT, pretty much states that if you have a smooth continuous curve f of x and you're starting at one point and going to another, that the slope of the secant line, somewhere between those two values, there would be a tangent line, a place where the tangent line slope is the same as the secant slope. So keep in mind, slope of the tangent has got to be equal to the slope of the secant line. So let's go ahead and use the points at 2 and 4, and let's see if we don't get a 2. So we get 12.8 minus 8.8 over 4 minus 2 is indeed 2. So yes, there is a time that does equal 2, and it's because of the mean value theorem. Notice, 1 point for the calculation, 1 point for the conclusion. Must use the mean value theorem. Try to write a sentence for this, but include the mean value theorem. Part C. Use a midpoint sum with 3 subintervals of equal length, so n is 3, in the table to approximate. And now notice, because we have a 1/6 there, we're dividing by 6, which means this is an average. So let's start off with midpoint. We need to know what we are skipping by. And skipping by is always b minus a over n. So we're going to go 6 minus 0 divided by the number of subintervals, 3, which is 2. So 0 to 2, 2 to 4, 4 to 6, all skipping by 2's. Now we need the midpoint between those values. So between 0 and 2 is 5.3. Between 4 and 2 is 11.2. Between 6 and 4 is 13.8. We're doing rectangles based on height. So 5.3 times 2 plus 11.2 times 2 plus 13.8 times 2. Calculate that out. Now they want correct units to explain the meaning of this. So this is the average amount of coffee that is in the cup during this time period. Notice 1 point for the midpoint sum. That would be this piece here. 1 point for the approximation, 10.1 ounces if you calculated that. And 1 point for the interpretation, the average amount of the coffee in the coffee cup over the time interval. Last part, part D. We're looking for the amount of coffee in the cup in ounces being modeled by this function. Using this model, find the rate at which the cup is changing. So rate of change would be a slope. So they're asking us to do b prime of 5. So let's do b prime first. Derivative of 16 is 0. Derivative of negative 16 e to the negative 0.4 would be negative 16 times negative 0.04 would be 64 e to the negative 0.4 t. Now we're finding b prime of 5, which is 64 e to the negative 0.4 times 5. Well, that's the same as 64 e to the negative 2, or 64 over e squared. So again, notice, 6.4, lost my point, lost my decimal point, losing my mind. Sorry about that. So let's see, 6.4 e to the negative 0.4 t, and then 6.4 over e squared. And again, don't forget your units, ounces per minute.